We are continuing with the Arenes. Now we study the mechanisms of electrophilic substitution reactions of Arenes. So question is, discuss mechanisms of electrophilic substitution reactions of Arenes, or that is for benzene. So we will be taking different mechanisms. First of all, halogenation. In this case, we are taking the mechanism of chlorination. Now, chlorination, we know it is the reaction of benzene with Cl2 in the presence of FeCl3 or Fe. Loss of HCl take place here and we get chlorobenzene. Now we want to know the steps of the mechanism, how this benzene is converted into chlorobenzene. So let us take its mechanism. It is believed that first step is the combination of Cl2 with FeCl3. 1Cl, this bond is broken up heterolytically. This will go up. This is heterocleavage. This Cl will go up with FeCl3 and will produce FeCl4 negative. Now once this chloronium ion is produced, it is highly electron deficient and it is again the viscous of chlorine which tends to remain electron rich always. Now it has generated positive charge. So next step will be attack of this in benzene ring. This pi electron come out. This pi electron go there, positive charge comes here. Again, positive charge rotated to ortho position. So this is your resonance in the chlorinated carbocation of Arene and a resonance hybrid of this. Positive charge flows from this position and comes back to this position. This is positive charge. Now this structure, it when combines with FeCl4 negative, Cl will be combining with H, producing HCl, and we get chlorobenzene. Loss of FeCl3 take place. So this is the mechanism of chlorination reaction of the benzene, and now we consider the mechanism of nitration. So all these reactions, they are to be activated by the electrophiles. These are electron rich deficient species. In nitration we know benzenes combine with concentrated nitric acid in the presence of concentrated H2SO4 at 330 Kelvin to give us nitrobenzene and water. Now let us see the mechanism of this reaction. First of all, first step is HNO3 combines with H2SO4, giving you NO2 positive ion plus H2O plus HSO4 negative. So these are the ions produced in the first step, HSO4 negative, H2O and nitronium ion. Since nitronium ion generated, it is electron deficient, so it will definitely attack benzene ring. So second step will be benzene now reacts with nitronium ion. This pi electron comes out at this position that form bond with NO2. positive charge lies at ortho position. This is your NO2 structure. Now it will exhibit resonance similar to the previous case. Positive charge comes here. Again positive charge goes here. Now resonance hybrid of this. Positive charge comes from ortho, goes to para, again comes back. Now this is the resonance hybrid. Now it has to lose this H positive. This will be going with HSO4 negative. It will take that, H2SO4 will go out and we get product nitrobenzene. So these are the two mechanisms up to now. We have studied halogenation, we have studied nitration. Nitration takes place through nitonium ion and halogenation through chloronium ion. Now we take the third reaction which takes place through the neutral electrophile, that is sulfonation. This will be our third mechanism. As we know, sulfonation, it takes place through sulfuric acid at 370 Kelvin. Loss of water is there. We get benzene sulfonic acid. Now we come to the mechanism of this reaction. 2H2SO4 breaks up to give you hydronium ion, electron deficient SO3. It will act as electrolyte here. And in nucleophile HSO4 here. This is electrophile. Although it does not have any charge, but it is electron deficient. So it will be in the search of electron, as was done by chloronium and nitonium ion. So this SO3 goes to benzene ring. This pi electron come at this terminus. Positive charge will go there, and it will produce a structure like this. This will enter in the resonance here. Now we see resonance hybrid. Positive charge flows from here. This is resonance hybrid. Now this resonance hybrid is now reacting with hydronium ion in the next step and will produce sulfonic acid. So this will be combining with hydronium ion and will give you HSO3. Now in the next step, HSO4 in nucleophile is there. It will pull this proton and will eliminate water, H2SO4, and ultimately we get benzene sulfonate. So this is the mechanism of Friedel the sulfonation reaction. Now we come to the next mechanism, that is Friedel alkylation. mechanism of Friedal craft alkylation reaction. सबसे पहले बेंजीन combines with methyl chloride refluxed with anhydrous AlCl3. It will produce toluene plus HCl. Now this toluene, how it is formed, let us see the mechanism. In first step, CH3Cl combines with Lewis acid AlCl3. This is Lewis acid, accepts chloride ion from here, giving you AlCl4 negative. This methyl carbocation will now attack benzene ring as done by the other electrophiles. This will now enter in the resonance. And its resonance hybrid will be shown like this. Positive charge flows from ortho to ortho position, and in the end you will be getting AlCl4 negative, which will be losing Cl negative ion in the form of HCl, and we get toluene. So this is the mechanism of Friedel-Crafts alkylation reaction. Then we come to the mechanism of Friedel-Crafts acylation reaction. Mechanism of Friedel-Crafts. This is our fifth mechanism, acylation. So first step here, first we will be taking the reaction. Benzene combines with CH3COCl, refluxed with waterless anhydrous AlCl3, giving you the product acetophenone plus HCl. Now what is the mechanism of this reaction? First of all, CH3COCl combines with AlCl3, giving you CH3CO positive plus AlCl4 negative. This is acyl carbocation. This is electron deficient and it is in the search of electron. So come to benzene. These electrons come here. CH3CO carbon will attack here. Ultimately we get product. This positive charge comes here in the next step. Now what is the resonance hybrid of this? Positive charge flows from this position to this. It will combine with this reagent AlCl4 negative, which will take up H from here and will give us acetophenone. So these are the mechanisms of electrophilic substitution reactions in benzene. Then we have one more reaction, that is combustion of benzene. If benzene is ignited, how do benzene burns? When benzene is ignited, in the presence of air, it will produce 6 CO2 plus 3 water. We will be having 9 by 2 O2 here. So this is ignition that should be done in the presence of oxygen. We will be using 15 oxygen here, so it should be 15 by 2. So this is all about your arenes. We have studied preparation of arenes, physical chemical properties of arenes. Then we studied the mechanism of electrophilic substitution reactions in arenes, and we got different varieties of compound from arenes. So this is all about the hydrocarbons. This was your second last unit, that was 13th unit of the 11th class, and we'll take up other unit. Thank you very much.